All right, so yep, my name's Jonathan Ball. I'm the product owner of the LINZ Basemaps service. LINZ Basemaps is essentially a collection of APIs that deliver LINZ's best data and a web map, so non-API users can explore that same data. I am meant to be here presenting with Blaine Chard, our solution architect, evil genius, but he couldn't make it today. As a result, the talk's going to be kind of more product-y rather than architect-y. Apologies in advance, but he has given me some slides, which he may have slightly dumbed down. In little letters in the bottom of the slide is our URL. If you feel like playing around with the service while I'm talking, it's probably more fun than the slides. It's pretty easy to use. You should be able to work it out, and it might mean you've got some good questions at the end. Let's get into it. What is a base map? You all know the answer to this. It's the thing at the bottom of your web map that puts everything else in context. But for LINZ, it's a little bit different. We see it more as a solution to a problem that we have. That problem being that we have an awful lot of data. Our open data portal has about 3,000 layers on it, and we regularly hear from customers that it's hard to find the right thing sometimes. They're just looking for the best, latest quality data, and we hope to make that easy for them. We have other problems, like Jeremy alluded to the number of web applications we might have across LINZ. We'd like them all to look the same. So basemaps kind of help us solve a problem like that as well. If we can all use the same basemap, that would be quite a nice result. But essentially, what it lets us do is reduce our large collections of data into a nice single endpoint that users can trust and build on top of. So to give you a quick sense of the problem, we'll look at one of our basemaps, which is aerial imagery. We hold a lot of data. So we've got about a petabyte of mostly aerial imagery, but a little bit of satellite, 5,000 historical surveys that are scanned in there, and we get about 50 new surveys a year. So it's growing really quickly. And those surveys aren't getting smaller, they're getting higher resolution. Councils are collecting more and more data. Should add, we collect all of the council's data in New Zealand and host it and share it out as a national collection. So that's how we end up with all this data. It means that storage and delivery problem just grows and grows. We used to have to send hard drives out. We got an open data portal, but that still only goes part of the way to delivering your best data. So we have ended up building a base map. And it looks something like this. I don't know if this is going to start playing. No, here we go. This is me just very quickly clicking through a range of the maps that we now offer. I'll go through them all in a little bit more detail at the end, but there's essentially 7 or 8 main services we offer at a national level at varying resolutions. Apologies for the janky mouse scrolling. All right, cool. So we have aerial imagery. This is how you see it when you first arrive. I don't know if any of the international visitors know this, but New Zealand is very sensitive to being left off maps. So our official government base map has left everyone else off. The map obviously has varying resolution data in it. It goes from satellite down to city and then to a property level. We have our 50k topographic maps in there and 250k, gridded and gridless. We have a vector topographic product, which can be repurposed into varying other maps. This is a more subtle property-based view. We have terrain RGB tiles, DEM and DSM, so you can look at the flat surface of the Earth or or the built and grown environments. These can be used for 3D maps, dynamic hillshades, elevation tints. Taking your map from that to that to that. We have some hillshade products. These are all at national scale, 1 metre resolution, DMs and DSMs, labels derived from those vector tiles, and also a good handful of historic data. When I say a handful, I mean like 500 historical layers, which you can now explore in 3D with labels. It's all very fun. They go back about as far as 1940, I think, is our oldest layer. So, very quickly, some of the design principles that were important to us when we built this. Wanted it to be low maintenance. We've often been a team of one developer. Right now we've got 3 developers in the squad, so we needed it to be easy to maintain. Scalable, because we like people using our product on Reddit or the news, and we want to be able to weather that storm. Highly available, because we are lazy and we don't want to work in the weekends. Traceable, because we want to know about problems before our customers do. And low cost, because you run a product at low cost, it avoids accountants and financial planners and people that see you making a successful product with hundreds of thousands of users and start to scratch their chin and wonder, how can this be monetized, or how much money are they spending doing that? Should we try and recoup some of that? So the lower we can keep our cost, the less attention we get from those folks. Now, into Blaine's slides. Basic architecture. You've seen this slide before today already. But yeah, essentially we can't deliver all of our data to every user every time they want to look at it. So we chop it up into nice little tiles. It's a tile server. We all know this. But here is our basic architecture. We've got storage, we've got compute, and we've got distribution. And it doesn't really get much more complicated than that at a high level. There are a few wee bits and pieces off to the side, but it's essentially those 3 main components. So let's look a little bit more at them. We have 3 things inside our S3 storage. We have cloud optimized TIFFs. These are the whole surveys, the whole aerial imagery surveys. There's hundreds of thousands of them, and we have them in multiple projections. We have cloud optimized vector tiles, which are pre-built. They're Mapbox vector tiles, and again we have them in 2 projections. We now have NZTM vector tiles, which is kind of an exciting new development. And then we have some configuration files. So this tells our basemap system what layers are available to it and what order they want to build a map in. So what zoom level certain layers should turn on and off at, and what order they should be. So, most of the time, 60% of the time when someone asks for a tile to be sent to their laptop, we already have it. It's sitting in CloudFront, so we don't have to do anything. But 40% of the time, we need to make a new tile. This is where our compute comes in. It basically reads from the S3, looks at the configuration file and says, what would go in this tile, draws in the TIFFs. Hopefully it's one TIFF that it needs to resize and crop, but sometimes it's, I think our most complex tile has 19 different surveys used in it, so it's quite a complex process sometimes to build those tiles. That can range, an easy one is sort of under 100 milliseconds, and a very complex one can be 500 milliseconds. Vector's a lot easier. It's basically just grab tile number 1/2/3, deliver it. So that's very simple. Again, I said those are all pre-rendered, just sitting there. We build them on a weekly basis in a different pipeline. And then you have distribution. So all of our AWS storage is in Sydney. We like things to run nice and fast for our Kiwi users, which is most of our customers. So we cache everything in Auckland using CloudFront. All right, so now I'm going to go into the section where we share some observations. So we've been running this service for about 5 years now, and a few of the little things we learned we thought might be interesting to this crowd, or might be a bit unexpected. Maybe they won't be. We'll see. The first is around vector tiles. So when the Basemaps project first got over the line, when its business case was accepted, it was based on a proof of concept map, which is what you can see on this slide. It was made from vector data, but rendered into raster tiles using lots of nice transparencies and blending options. And it made a really lush visual product, something that definitely compelled our leadership to sign some checks and get the project underway. Like it was a nice map, and people wanted to see it happen. Once we got the money, we went and built the aerial imagery map first for internal business reasons, but then we came back to the true colour base map that was sort of meant to be this. At that point in time, vector tiles was, they were fairly popular, and it was clear that they had a bright future. There were heaps of things about the technology that we could see were useful and we wanted to embrace, especially labelling, rotation, about clarity of line work. We were really into all of those things, so we doubled down on vector tiles. But we didn't quite get to where we wanted to be visually. Like, we were never overly happy, and we never managed to achieve this level of sort of beauty. What we have found recently, though, with the way vector tiles are delivered, as generally we give our customers style JSONs, which describe how to render the vector tiles, and inside those style JSONs, it's now really easy to bring in other sources, whether those are RGB terrain tiles or raster layers. But using those additional sources combined with the vector tiles, we're finding you can get a really high quality visual output. So really crisp line work, but nice smooth gradient. So this has got a Map Libre hypsometric tint in it. It's got a DSM Igor hill shade. It's got vector tiles. Yeah, so it's combining all of these things, and it's getting to a point where we're getting quite happy with it visually. This isn't in production yet at all, and maybe never will be, but we're kind of excited about the future of combining all of these different tools. But it's quite a new place to be doing cartography inside the style JSON and combining the different sources. Next is playing fast and loose with new technology. We're not a legacy product. We don't have legacy customers or any legacy tools. We've been able to adopt new technology really easily, and that's made life really fun for us and our developers. We use cloud optimized TIFFs to store all of our data. Map Libre is the map viewer, which always comes with cool new tools that just appear, and it's fantastic. Terrain RGB tiles have been really fun to play with. And we've just started using shortbread as the schema for our vector tiles. So, well, yeah, it lets us adopt these things nice and quickly. Obviously, as we mature, we'll end up in a more difficult place there and have to start managing that better, but for now it's nice. You might remember this slide from Jeremy's slightly different treatment, but a slightly different point. One of the secrets to our success is building on top of large, standardized collections. So when our data is already sitting in a nice data lake with great metadata, you can make a national base map very, very quickly. If you have to go and start working with a business group whose data is not in that nice standardized format, it can take 20 to 40 times longer. Data wrangling is hard, but you'll probably know this. Next, working on top of AWS's Open Data Registry is another key to the product success. It saves us a lot of money on storage and egress, but it improves transparency. This is why we have cloud-optimized geotiffs available as whole surveys. It's part of the pipeline of getting, well, originally it was part of the pipeline to get data into basemaps. Now it's its own thing in its own right, but it improves access to data, and it also very well aligns with our views and goals around formats. So to store data in AWS under these sorts of agreements, you need to be using cloud-optimized formats. Almost last, maximum focus on reuse. Well, we simplify our lives and the amount of businessy type work we have to do by being open at every possible opportunity. We use our APIs are all free and they're all open. We use open libraries to distribute the data, to view the data. Every piece of data within the map has a Creative Commons 4.0 license, and if it doesn't, it can't go into the map. We use open standards. We develop in the open. Our source code is all open and replicable. We contribute to open source projects through code, funds, and membership. Yes, I think that's about it. Here's a wee snapshot of our last 5 years, just ticking over 13 million tiles at the end. The big green blob on the right is aerial imagery, so it's our bread and butter. It's where we get most of the value out of the product, but you can see our other maps growing in popularity, which is really nice to see. Yeah, I think that is about it. Cool, thank you very much.
Questions?
Cool, thanks, and great talk. So we deal with a lot of time series satellite data that sort of has a time dimension back through time. These are all, I think these seem like sort of static products. Have you had an experience with time series data and kind of visualizations that you can kind of scroll back and show different time steps?
Yeah, we would love to do something like that, but it will introduce a lot of complexity. But that's not to say we won't ever do it. We might start in a really simple fashion. Like at the moment, our configuration says put the best resolution, newest data first, right? And we could literally reverse that and serve the same base map in a different order, like the oldest data. But in terms of actually letting people scroll through time, we haven't, but we know the tools are kind of there. Yeah, something for the future maybe. It's definitely an idea box on our roadmap, but not something we've committed to in any way.
Actually, could I just ask a question that's sort of related to that? Mm-hmm. Do you have any rapidly changing data sets, and have these presented any challenges to you, just in general?
Well, if you zoom right in to our topographic vector maps, it's got New Zealand property data in it, so property parcels, roads, addresses. There's a lot of change in those data sets on a sort of weekly basis, so we reproduce those vector tiles weekly. Faster than that? Not yet. Not yet. Okay. No. We are used, though, within emergency management applications, so sometimes we will publish data in emergency events, and our platform is used to get data out quite quickly. Yeah.
Okay, thanks. Any more questions?
Less of a question, more of a statement, kind of related to the last question on the last session about cost saving, and just thinking about that from a all of New Zealand perspective, like the cost savings to businesses and the community and geospatial are like huge for using Basemaps and LINS data service. You think about not having to download, manage, store, host all this information ourselves. We can just point to the APIs and use it. Yeah, it's amazing. So thank you to you and the rest of the LINS team. It's game changing. Yeah.
Thank you. A lot of these guys do that fantastic work. There's a lot of people here that contribute to that. So thank you.
Yeah, great stuff. Your JSON catalog, was that pre-stack? And are you going to be turning it into stack?
I don't know. No idea. I haven't heard anyone ask that we spend time on that. There's stack metadata for every one of those cloud optimized geotiffs and the vector tiles, but I don't know if we've considered turning the configurations into stack. No, I've not ever heard anyone ask that. I will go away and Google why we might do that. I'll ask Blaine.
Any more questions?
I was just wondering, I saw Argo workflows pop up there on one of your slides. Just curious, is that what you're using to, I guess, process the, or cut the imagery and cut the raster data into tiles?
Yes, Daniel's nodding. Yeah.
Okay.
Yes.
Oh, awesome.
Yes,
Thanks. Yeah, I was just curious. Thanks.
Thanks, Jonathan. I've got a question around the product vision around the existing data LINS portal, which is lovely, and this new basemap service website.
You mean the LINS data service?
Yes, LINS data service, yeah. Where do you sort of see the line between functionality, what belongs in the basemaps versus what belongs in the data service tool?
That's a really good question. I see the LINS data service as a prime customer. They should be consuming our basemaps and there should be good alignment across all of LINS's web apps. Would it be nice to be able to serve the basemap out of the LINS data service as well? If people went looking for it, that would be very cool. But when the idea was conceived, it was focused a little bit more on the developer community and looking for those customers that can get us sort of an amplification, or so one developer gives us 100 end users or 1,000 end users. So making a service that's really easy to be built on top of by developers. And the LINS data service is just a little bit too dynamic, serving to such a wide range of customers that it can't really be focused on just pouring out tiles as fast as it possibly can. Just don't have enough control over the infrastructure to be able to use it like that. Does that make sense? Yeah. So targeting the developer persona, really.
Any final questions? Yep, got one there.
Thanks, Jonathan, and LINS team. Your basemaps are awesome. Just two questions. So your usage stats that you had up before, I wonder if you've looked into what proportion of that is public organisations versus like private business, etc.
Not exactly, but this is our own apps.
Yeah.
So a good proportion, like
Yeah.
10% or something like that.
Yeah.
Better
Okay.
maths.
Second one, the previous presentation had a success factor or goal for Lynn's for incorporating AI into things. Have you got any of that on your roadmap
No.
planned? Yeah.
No.
Okay.
But we'll use it when something pops up, I'm sure. Other than writing product updates that I email out.
What's the blowed out stuff?
Cost, AWS cost.
It's pretty small.
Yeah, if you squint, I'm sure you can make it out. It's a very small number.
Classified version.
Yeah.
Okay, please join me in thanking Jonathan.
Thanks, guys.